what are we up to today? Well, today we're going to be making a 12 volt UPS. Now, this uninterruptible power supply looks a bit like this when it's complete. We have a power outage coming tomorrow, and I'd like to keep my cameras alive. So we have 12 volt wired in the house off a solar system. This is a little circuit board that I designed up and had manufactured with PCB way, I think. Basically, we take a DC from the battery in here, a DC from the mains plug pack here. If the mains plug pack drops out, then things should run off this capacitor for a brief amount of time for that relay to close shut. This diode here, while it does create a half volt drop, prevents bleed back from the main supply back through the relay, so that the relay isn't held closed by the battery supply. It's fairly simple. With this basic board, we do have an output LED to indicate what's going on, and we can have an input as well. I usually leave one or two of them out. We have a diode and we have a resistor here to run the LED. We have a diode here to stop the flyback across the coils, and a capacitor to help absorb some of the spike long enough for that diode to become conductive. I have another 390 ohm resistor here to run the LED, and that's more or less it. It's all just down to a bit of trickery in basically the wiring of the relay. So yeah, let's get cracking with the assembly. Start with some of the discrete components first. I have here a big roll of resistors that are coming out of the paper. These are, what are we, orange, white, black, red. I gather from the fact that they are blue, they should be a metal film resistor, and red I think means 2% tolerance, and that should be 3900, so that makes it 390 ohms. So I've got one of them, two of them to put on the board. Right, I'll do that. Now I need to find some 1N4004 diodes. Now the power side of this, I'm probably going to stack two or more in there just to increase the current handling. Let me find those. I have a box of parts that was given to me by the late and great Ken Anderson. There's a video about him way back as well. It's halfway through a project to impress him when he fell off the perch. It was probably a little predictable considering that he had bowel cancer. But yeah, he was a great advocate of the Assisted Dying Act, and I have reason to believe he might have been the first candidate of that, but you know, privacy and all, I don't know for sure. And that resistor is an old one out. We've got two of those. We're probably going to need probably a couple more. Alright, let's get them out of the way. What are we going to need? A couple of LEDs next. So let's find them. Another couple of boxes in here. This one has real-time clock chips, RJ45 sockets. These are nice. These are little Arduino boards with a USB interface. I'll have to play with them sometime. Opto couplers. Oh, and we're going to need a couple of these guys. Chuck them in here. Where are we? Now, condenser mics, no. Get rid of them. What color LEDs do we want to use? I tend to use green for mains and red for battery. Gives me a pretty immediate indication as to what's going on. So let's do the green, or let's do a blue one because it's less likely to arouse suspicion in the dark. Only slightly. Now, let's get some of these components placed in the board. I'm going to do the discrete components like the diodes and resistors first. There is a bit of background noise you will notice from the last clip. That is the air conditioner. Multiple sclerosis is taking a bit of a toll on my temperature tolerance. Anyway, the way I made this board, I need to check how wide I needed to put these in. Some of them I made them very tight tolerances. So let's grab a pair of these guys. I think I can pretty well eyeball these guys. They need to be about just in from the end there, like that. That should be about right. Make our 390 in here. Now, There is a lot of conjecture when you get to this bit. I didn't get that quite right, but that doesn't matter. Give it a tug from the other side. Alright, a lot of conjecture about how to do this. I like to fold my leads like that so my components stay in there. And then I like to put a few components in whilst I'm doing that. Make this one a bit longer this time. And do that. So 390. I think I used Design Spark. That's the free tool from RS to design this board. It's not a bad tool. So I think what I've been doing in the past, I've actually been mounting one diode on the front and one diode on the back, and I think I'm going to continue to use that method. I'm going to do this and this, and these have got slightly thicker legs. I should have bought more quality ones because these ones don't really have very thick legs, and I think that has something to do with how hot they get. Alright, so let's put our diodes in. So that's our input, which we're going to indicate is green. We'll whack U in, and again I'm going to push down firmly with my thumb here, and I'm going to push the legs either side a little bit. Let's put our blue in this way. Which way is our flat? Our short leg is our flat side. I better just double check I got that other one right. So our big terminal is also on the flat side. Yes, that appears to be correct. Okay, let's solder these. Now, to keep everything in place, I'm going to put a little bit of blue tack under here. I'm going to get my 6040 tin lead solder. Now I'm going to add more noise here. I'm going to bring my extraction fan overhead, and I'm going to commence soldering. So let's go fan out. It's a little on the noisy side. I hope you can deal with it. Let's do this. Right. There we go. Now, there's two different techniques. If you are dealing with non-flux solder, you would put flux on here, and then you would heat the solder. You could heat the solder on your iron and bring it to the junction. Because I'm using flux core, I'm heating the wire and the pad at the same time, and I'm feeding the solder in to the two. So I'm letting the wire and the pad effectively melt the solder. And I find that leads for a very nice clean join, or makes for a very nice clean join. Alright, now we're going to trim these off. Right, now if you're getting flush cutters as opposed to side cutters, these are regularly confused. Flush cutters are designed with blades so they sit flush. Side cutters leave a little bit of distance on the cable, or a bit of length. These are really good. I can get them right just on top of that solder ball, and I can shoot these leads up straight into my eye. So, if you don't like wire in your eye, it's probably, unlike me, you probably want to wear some safety glasses if you're doing this. There we go. Alright, so that's the base parts of it. And oh, by the way, I'm covering this up just because it's got some personal details on these boards. It's really designed, if you come across a piece of hardware and this is inside it, I'm going to want to hear from you if it's failed. But I don't really want the general public having some of that detail that's on the board. And I know that sounds a little bit hypocritical. Right, so this is the bleed back diode. Without this diode, the whole system won't work. I'll make sure I get that the right way around. Otherwise I'll have a dead short until it blows up. I'm going to solder this guy in, and I'm leaving these leads straight for a good reason. Now I need to observe the position here, so our white stripe is there, so our white stripe's that side. Diodes of course are polarized, as are LEDs, because they are light emitting diodes. Let's see if I can go with this. Yep. Now this is where flush cutter come in handy. Let's just double check that our diodes are the right way around. Now we can go flush cut off here, flush cut from here, flush cut from there, and a flush cut from there. Now we have a parallel diode on the back, and that will sort of double our current handling, in theory. Now, I'm going to squeeze a slightly bigger capacitor onto this one. This called for a 4700 mic cap, which is what I initially estimated would do the job. I couldn't get a 16 volt one, so I got a 50 volt, but that won't hurt it. Next biggest components, you'll notice when I do this, I kind of cocked up when I made the board, and I put the trace on the wrong way round, or on the wrong side of the board. For some reason, when I do this in Design Spark, it flips the pins in the wrong direction, so I have to make a slight mod to these guys. I've got to take that side pin and fold it up. So again, we take a side pin here, nice and flush with level, fold it down. Right, now we plonk one of those guys in here facing the edge of the board, and I'm going to hold it down with blue tack, keep it nice and flush, and we do these guys one at a time. These need a fairly considerable amount of solder, and I'm also carrying quite a bit of current on those tracks, so I've made the tracks as big as possible, consuming all the available space that's there. There's one on. I'm going to need 3 of these. I'm smart. I didn't read the silk screen. Okay, you can go in. Let me just double check I've got that positioned right. I do indeed. Let's do one of these guys. Whole bunch of... yeah. Right, let's grab ourselves another socket. Alright, it seems I had one lodged in my airway. Alright. There we go. One of them. One of us. One of us. Alright. We'll stick you down. It's nice when you make your own boards. Everything goes together nice and smoothly. Generally the way you designed it. I guess, unless you're me. And sometimes not the way you designed it. Alrighty. There's our sockets. Let's whack a relay in next. Plonk you in. Now I've indicated the positions are normally open and normally closed, and they correlate with the relay pins. If I get them backwards, we're going to have a bit of a short out of there. Fortunately with this balances nicely on the relay, so I can solder that center pin to get it positioned, and I can work my way towards the back and get some nice solder pins there. Alright, so all we need now, alright, now I did have provisions here for a little self-powered LED meter. I'll show you one of them. Actually, I can do that right now. I'm going to pick the camera up. We go up the top here, and there is one hiding away up here, and there's a little LED meter hiding on it. Let's see if I can detach from my tether here. Alright. That one up there is running my NBN modem. Now, we do need to reattach to the tether, otherwise my battery's going to go flat. And of course, reattaching to the tether does tend to reset the recording. Now, this capacitor is considerably bigger than the silkscreen, so I'm going to pull a little Swifty here and squint these leads in a little bit. Now, that is, I think, the negative. It's like, I'm a negative, it's screaming at me. Now, this only just fits through these holes. Alright, so this was designed to lay the capacitor down on this board and then strap it down, but I'm not sure if I'm going to get... or we will. I'll just whack a little bit of insulation tape under that diode, and I'll hoik this up a little bit. In fact, a bit of hot glue might even do that job. Blue tack to the rescue again. Let's double check I've got negative on the right side before I do that. Yes, I do. Okay. Let's whack you in here. Let's hold you on. Let's hold you on. And we're pretty well done. Quick builds, these ones. I'll get some cleaner on the back there in a minute. I'll whack some hot glue on to hold this capacitor in place, but that should give us a power supply, or an uninterruptible power supply. Let's be back once we've done the hot glue. We've got our board sideways. I have Mr. Stoner Torch Blue. He's going to heat some hot glue because hot glue guns blow up on me all the time. Me and PTC heaters are not a good bedfellows. Now I'm going to have to keep my hot glue away from that diode because depending on what I'm doing with it, it can get quite warm. So I'm just going to get a nice blob of this hot glue heated up here. I'm going to wedge that under there. I'm just going to keep building that up until we have a suitable glue bridge under it. Oh, almost there. Let's just drop this down here now. There we go. Not the greatest hot glue job, but it should secure that all the same. And crucially, if you look in the side here, there is a tiny little gap above that diode there that allows a bit of airflow. And it also means it probably won't melt all the hot glue on me. Alright, so we'll get this one on the test in a moment, and hopefully it does what we want it to. Okay, so we've migrated a little bit towards the messy end of my bench here, but we'll see how we're going here. So this little plug here, this little pluggy, is the mains power supply. Wow, that blue light is going to be really bright. Alright, well at least I'll be able to see from a distance. I might even have to put a lower or higher rated resistor in there. So now this is our battery supply. So this will go in. Now if I unplug, that should turn off and our blue light should stay on. That's pretty good. Now I'm going to see if that blue light goes off because I'm smelling something getting hot. It could mean I have a diode backwards somewhere. Oh, the flyback diode was getting very hot. I wonder if that is a problem. Yep, and so let's see if I'm getting power through here. I am indeed. Flyback diode doesn't seem to be getting hot. There we go. Well, okay, so it is getting power through the 12 volt side, that's fine. And that is alright. You know what I am going to do? I'm going to leave that run for a bit. Oh, and that flyback diode is getting really hot. I might get my thermal imager on this. Give me a moment. Alright, here's my cheapy Chinese thermal imager. I also found this was stuck to the blue tack behind it, which could account for something. Alright, so here's our board. Can we focus on that? So something's running at 60 degrees. Let's run over here and see what else we've got. So this is over the LED area. There's a little bit of warmth surrounding that LED. That's fine. We come up along here. This will be, so that hotspot to the upper left of your screen, to the upper right of mine, will be probably that diode. Yep. So running about 60 degrees. Let's turn this over, have a look in under the, oh wow, that just burnt me. That is running really hot. Alright, where are we here? So that is, I want to see under that capacitor and see if I can see that diode running real hot. It doesn't seem to be running real hot. Probably because there's no load across that at the moment. So, alright, well, that guy, we can feel that is running really hot. It's not the end of the world if that guy burns out. I'm just hoping I got the polarity right on that. Let me check the other one. No, that looks to be correct. Yep, it's about right. Guess it doesn't like running as a flyback diode. Oh, it can stay there till it burns out. It's not going to destroy the circuit if that burns out. That's just to protect really the relay and a bit of spike, and we've got a big fat capacitor here anyway, which will handle the spike, and way up to 50 volts as well. Alright, I'll try one last thing. I'll see if I can find something to run from this. Alright, well, I couldn't seem to find anything productive that would run from this in my collection at the moment, aside from a camera, which is going to involve me publicly showing where all my cameras can see. I'm not keen to do that. Anyway, I have a big fat 135 amp hour battery that I use for the trolling motor in my Argo. I'm going to attach it to this and also the main supply for a couple of the cameras I have running at the end of 100 meters of cable. So when our power flips over tomorrow and the partner to this, namely this guy here, runs my DVR, that should then mean that I'm running on battery, and that should run on battery as well. So we should have pretty much about 50% of our cameras running for the duration of the power works, which will be nice because I do have some neighbors of which I won't really go into too much detail about, but there is a little bit of concern there that when the power's out I might get a visit from them that I'm not aware of. So I would like to sort of have some record should that unlikely event occur, but it's also a good chance to experiment, and that capacitor is really holding some charge. Let's actually, one experiment I will do on camera. We'll charge both of these guys up. Oh. We'll see how long they both last in comparison to each other. This one I had on the wall and it was running all night. It's got very dim now. So this capacitor's got a lot more capacity, even though they're both 4700 mic. That one is a lot better capacitor. So that one might go on the DVR and that might go on the cameras. I don't care if the cameras reset and have to recalibrate. It's the DVR I don't want resetting midstream and corrupting the drive, which has happened before. And also SSDs in constant use on DVRs are not a great thing either. Just as a little side note, this is an ADATA one and it's only got 2 modules, 512 gig each. One module died, so 512 gig disappeared off the board. Haven't quite worked out whether it's just a power regulator yet or whether I can really recover data off that, but I might be trying a chip off data recovery at some point. This guy is still going. Although I guess blue LEDs have a different forward bias voltage, and also as the voltage drops their current usage drops dramatically as well, so this could well do this for hours. Anyway, we know that capacitor is probably better than that one, or it could be just that I think the gallium nitride, somebody will correct me on that, the red LEDs anyway that use gallium, probably a little bit more power hungry anyway. All the same, hope this has been interesting, and we'll see you all in the next video. Now I thought I'd add an addendum to this. This has got my DVR in its power off state, so I'm not going to damage the drive. I'm going to pull the main supply to it, and we still have a DVR. And you can see here we've switched over to running off battery volts. So the blue LED has gone out. That's probably a voltage drop issue. And let's go down to the desk, and we can see we're pulling about 2 amps, which is what I would expect. Alrighty, that's the real end of the video. See you all later. Hope you had fun. Give us a thumbs up, I guess. See you later.